Now, we can also use differentiation to help us with these functions of time. Let me give you an example. A particle P is moving on the x-axis. At time t seconds, right, the velocity of P is v meters per second in the direction of x increasing, where v can be modeled like this. Find the acceleration of P when P is instantaneously at rest. So, the first thing we need to do is work out at what point v is at rest. The way we do that is we need to set v equal to 0, okay? Now what we need to do is let 12 minus t squared equals 0. And for sake of argument, I'm also going to make t squared positive. So just times everything but by -1. Now, let's think of two numbers that add up to make that, but multiply to make that. 3 and 4. X minus 3, x plus 4. Although, sorry, it's t in this case. Let me just rub that out. And that's equal to 0. So therefore, t is equal to 3. And we disregard the 4 because it's going to be -4, but we can't have minus time. Right, now, we know the time that we're looking for. Remember, though, if this is the velocity function, how are we going to work out the acceleration function? Remember, if v is a function of time, right, then the acceleration is the gradient of the velocity. And the distance is the area underneath the velocity. Okay? Remember this till the end of time. It's going to be very important for these upcoming 2 lessons. Anyways, so how are we going to work out the acceleration? Well, if v is equal to 12 minus t squared, a is going to be d v by dt, which is equal to -1 minus 2t. Okay? Now, we know that at this point, time is equal to 3, isn't it? So therefore, a is going to be -1 minus 2 times 3, which is equal to -7 meters per second squared. And that is your final answer. Is that explanation good for you? Well, you can subscribe so you never miss a single explanation from me ever again. Now let's look at this one. A particle is moving in a straight line. At time t seconds, its displacement from a fixed point is given as this. So find the distance between the 2 points at which it's instantaneously at rest. Now, remember what we said here. If x is equal to 4t cubed minus 39 t squared minus 120 t, remember, the gradient, right, is the velocity. So dx by dt is equal to v, which in this case is, come on, let's differentiate this. 12t squared minus 78t plus 120, okay? Now, the points at which it's instantaneously at rest, what would it equal? It would equal 0, won't it? So therefore, let's work out the points at which it's at rest. First thing I'm going to do is divide everything by... Can I divide everything by 12? No, I can't, and I don't want to. let's just do this the old-fashioned way. T is equal to 78 plus minus the square root of 78 squared minus 4 times 12 times 120, all divided by 24, okay? So if you plug that all into your calculator, we're going to get an answer of t equals 4 and t equals 5 over 2, okay? All right. Now, what are the points at which, how are we going to work out the distance at which these two were simultaneously at rest? Well, the first thing we do is we need to find x when t is equal to 5 over 2. X in this case would be 4 times 5 over 2 minus 39 times 5 over 2, cubed and squared respectively. This is plus, sorry. Minus, plus 120 times 5 over 2, okay? And if we plug all of that into our calculators, or if you want to do it in your head, you also can, you will get an answer of 118.75 meters. Okay, sure. Now, same thing, where t is equal to 4. So x is equal to 4 times 4 cubed, minus 39 times 4 squared, plus 120 times 4. Again, put that into your calculators, and we will get an answer of 112. So all we need to do is work out the difference. The change in distance is just going to be 118.75 minus 112, which is equal to 6.75 meters. Does this still not look right to you? Well, you can ask me whatever you want in my Discord server for fast responses. Now let's take a look at this one. A particle P moves in a straight line. At time t seconds, the acceleration P is a, and the velocity v is kt minus t squared, where k is a constant. The initial acceleration is 4, so find the value of k. Right, okay. So we're told that v is equal to kt minus 3t squared. If that's the case, then what is the acceleration? Well, the acceleration a is equal to dv by dt. Of course it is. And doing that, we will get k minus 6t. Okay? Now, we're told the initial acceleration of p is 4 meters per second squared. That means that this is equal to 0 when t equals, it's equal to 4 when t is equal to 0. Okay? So if k minus 6 times 0 is 4, then it means that k is equal to 4. Standard stuff. Now, using the value of k, find the acceleration when p is instantaneously at rest. For this one, all we need to do is say that, if we change the sides, 4t minus 3t squared is equal to 0. That means that we need to work out what t is. T is either equal to, we factor out t and we get 4 minus 3t, which means that t is either equal to 0 or is equal to 4/3. Yeah? Those are the two times where t equals, where it's stationary. So therefore, a is going to be, let's use our gradient function. 4 minus 6 times 4/3 right? Because we know what it is for 0, right? It's 4, isn't it? Given in the question. But for 4/3, we plug that in. And we get an answer of -4 meters per second squared. Thank you guys for watching. I hope this video made sense. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me today. Drop me an email and we can organise a meeting. Keep on learning as you have no idea what you're capable of doing.